Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. If you've watched this video series as I've laid it out, you know that we're in the middle of working with rational functions. And we just finished graphing rational functions, which was a very, very long section and a long video, to be honest with you. The last video in this section, though, is pretty short. It's just solving rational inequalities, and we have all the skills we need up to this point to do so. I just didn't include it in the last video because, well, it was a long enough video as it was. So let's go ahead and talk about how do you solve a rational inequality. Now, I'm taking a very simple one here, but they could be as complex as I want them to be, and the idea is still the same. What a lot of people have learned from the past with solving rational inequalities is they multiply both sides by the LCD and all this other stuff. The problem with that is that when you multiply both sides of an inequality by a variable expression, in this case x plus 2 and x minus 7, you have no clue if those are positive or negative. You have to build sign charts. It's a little bit convoluted. And you don't get to practice a very important skill in the process. So what I like to do is actually get you to practice a skill while still solving an inequality. And here's the skill you're going to practice: graphing. Let's just move this statement to the other side. So we're going to add 4 over 9 times the quantity x minus 7 to both sides. So that will imply that we have 0 is now less than 5 over 9 times the quantity x plus 2 minus 4 over 9 times the quantity x minus 7. And now we'll do good old arithmetic, right? Find the LCD and get these with like denominators and add them up. So I'm going to attach to the first fraction, both numerator and denominator, the x minus 7. So here we go, x minus 7 down there, x minus 7 up top. And on the second fraction, I will do the same thing, but attach not an x minus 7, because it already has that, but the thing that it's missing, which is the x plus 2. And we arrive at that. Now that they have the same denominator, we can glue these together. Very, very nice. Nothing super crazy. This is what you have had for years in your algebra courses as far as working with rational functions or rational expressions and adding them up. So none of this should seem daunting to you. But then you get here and you ask yourself, what are you supposed to do? Well, you should distribute out the numerator and collect like terms. Don't worry about the denominator. The denominator is perfect the way it's written. But the numerator you want to clean up quite a bit here. Nothing big, right? 5x minus 4x is an x. Let's see, minus 35, and let's see, minus an 8. So minus 43. Let me just double check my mathematics. 35, lose another 8. 43, yeah. And this is all over, again, 9 times the quantity x minus 7 and x plus 2. There we go. Now, if you quickly graph that, nobody's asking you to graph it, so you can quickly graph it. You can just kind of etch-a-sketch it out, right? Just really quickly go. So I'm going to put a vertical asymptote at 7. I happen to know that vertical asymptote has multiplicity odd, and another vertical asymptote at x equals negative 2. Again, I'm assuming you've watched how to graph rational functions. And I also know I have an x-intercept at 43. Well, that's way off to the right-hand side. So I just rescaled things really quickly. Nobody's judging me or looking at this graph, so I don't really care. And finally, I'll find the y-intercept. And that is just allowing x to be 0. If you allow x to be 0, you get a numerator of negative 43 and a denominator of some negative number, right? Negative 63 times 2 is a negative number. I don't really care what it is. The main thing is that it's positive. Negative over negative is positive. So I know it's like this. Now, I can graph. Start with a point, usually the y-intercept. And in this case, I have a y-intercept. That's perfect. I can't go down from there because if I do, I hit the x-axis. So it'll have to go up. Roop, roop, right? Now, each of these intercepts, vertical asymptotes, have odd multiplicity. Not only that, but I need to draw your attention to something else here. This is degree 1 upstairs, and that's degree 2 downstairs. So I know the horizontal asymptote is y equals 0. That's going to be important, okay? So here we go. Let's see if these are odd multiplicities as far as the vertical asymptotes go. You know, it's the opposite behavior. It's going to want to go through x equals 43 like a line. But remember, over the long haul, it want to hug the y or x axis here because, again, the horizontal asymptote is 0. Along the same lines, since negative 2, the vertical asymptote at x equals negative 2 has odd multiplicity, again, the behavior is opposite and it'll want to eventually hug the x-axis. It will never cross the x-axis because there's no x-intercept on that side. All of that is because, I do all of that because I want my function that I just graphed to be positive. I want it to be greater than 0. I want it to be above the x-axis. And you can see it right from our graph, where that curve is above the x-axis. So you're going to list out the x values for which your curve is above, strictly above, by the way, right? It's strictly greater than, let me point an arrow at that, strictly greater than. So you want your curve strictly above the x-axis. And that happens from negative 2 to positive 7. And then from, so I'll put union here. Remember, this is 43. So from 43 to infinity. And that is the solution to that inequality. It happens very quickly. So once you know how to graph and once you're super comfortable with graphing, you can do a lot of these very, very quickly. For example, in our last lecture, we dealt with this beast of a rational function. And I generally sneak this in as a double whammy here, where I have you graph this, and then later on I say something like, oh, hey, I'd like you to solve the inequality, and it's the same exact function, but maybe I want it to be less than or equal to 0. So I would say solve something like, again, that same rational function, but less than or equal to 0. Well, if you've already graphed it, then the solution is staring at you. You just want to know, when are the y values of this curve at or below 0? When are the y values of this curve at or below 0? They're at 0, by the way, at x equals 2 here, because that's where it struck the x-axis. But really from negative 2 to 7. All x values between negative 2 and 7, not including the edges because those are vertical asymptotes. So between negative 2 and 7, you have a solution to that inequality, t of x being less than or equal to 0. Very fast to solve rational inequalities once you know how to graph a rational function. All right, so again, I recommend you go back through all of my rational functions I handed out in the previous examples, so like this guy right here and whatnot, and ask yourself the same questions, right? When is this graph above 0? Now, some people will also ask, hey, but won't you ask something like, when is this function greater than 1? No, I wouldn't do that, because that would be very, very challenging for you to figure out. I could, I guess, ask, when is this function greater than 4/7? The only reason why I would ask that, though, is because the y-intercept for this function is at a height of 4/7. And if you look at your graph, if this, let me point an arrow at it, if that's a height of 4/7, then you know that all of these values here are above that height. And by the way, so are these. But to be honest with you, I think that's a bit of an unfair question because of one simple yet elusive concept, which is that you're not 100% sure if your function went up a little bit and then came down. You have no clue. So that's a very unfair question. It's really almost always going to be, when is it greater than or less than 0, or greater than or equal to 0, or less than or equal to 0. Or I suppose that I could do it, give something like I did with the very first problem in this video, where I gave you a rational function on both sides and you had to move everything to one side. But at that point, again, you're just dealing with a rational function being greater than 0. So please practice graphing rational functions. They are not too terrible once you get used to them. They're actually pretty fun. You just have to get used to them. All right, that's all I have for this video. It's kind of nice.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.